So hello everyone. Today we are going to discuss that one question number 8 from this week 4 assignment 4 of the NPTEL course Introduction to Machine Learning. Okay, so what it is asking in the question is that they're asking to train a SVM classifier on a modified iris dataset. Okay, so the iris modified iris dataset they have already given in this link, which I have downloaded. Okay, here in this link iris.x.csv and iris.y.csv is given. Iris.x.csv is having all the 4 features of the iris dataset, whereas iris.y is having the target values, okay, the target classes of the iris dataset. And they're asking to use sklearn library, and this time they're asking to use only first 3 features from that iris.x.csv file. And what they are asking to try different kernel and associated other parameters. They are asking to use the RBF kernel from of the SVM classifier that is there in the sklearn library, and the gamma value they have specified as 0.5. They are asking to use one versus rest classifier, one versus rest approach, so that we can do multi-class classification for the iris dataset. This SVM classifier, it is inherently a binary classifier, but that means it can classify on all those data sets which are having 2 classes, but the iris dataset it is already having 3 classes. So for multi-class classification we have this approach one versus rest. Okay, so they are asking us to use this particular um, mode of that SVM classifier, and they're asking not to use any normalization on the feature. Okay, before training our data on the SVM classifier we have an option that we can normalize those features, but in this question, in this setup experimental setup, they are asking not to use any normalization, and the C value that they are suggesting are to use 0.01, 1 and 10. For all these 3 C values, whatever accuracies we are going to get, okay, out of all those, the best accuracy we are asking to find. Okay, so here you can see what we have loaded, NumPy library for doing some manipulation on the on NumPy arrays. Then pandas we are using because we are loading a .csv file, and also we are using some function from ilog function from the pandas. Then the SVM classifier is there in the sklearn library with the name as module name is SVM. Okay, and out in this module name there is this SVC function which will do that classification of SVM. Okay, and finally we need to find the accuracy, so we are using accuracy score from matrix module. So what we have done, we have loaded the data set, loaded the X feature values into the data frame X, and the Y target values to the data frame Y. Then since they are asking to use only the first 3 features, so what we'll do, this particular data frame is having all the whenever we have loaded, it is having all the features, all 4 features of iris data set. Okay, but we are using this ilog function of pandas. We are taking here all the rows, okay, and only up to 3 columns, first 3 columns we are taking, and then you again from the data frame Y, using this ilog function, what we are doing, we are taking the last column. -1 means here column means all the rows, and -1 means on the last column, or although it is having only one column only, so we will definitely going to get that values of that column in my y y array. Now again you see, after that we have used this ilog function. It is a pandas ilog for indexing. Then we have used dot values. So using these dot values, it will convert the data frame, the feature extracted feature from the data frame to numpy arrays. Okay, so after that what we need to do, we need to use what the setup was. This was the setup. Use the first 100 rows of the training as the training data and remaining 50 as a test data. So the data set that we have downloaded, it is having 150 number of rows. Only the first row 100 rows will be in the training set and the rest of the 50 rows will be in the test set. So that's why what we have done, from the text we have selected up to 100 number of rows in the x string variable, whereas after 100 the rest of the 50, okay, 100 column, it will extract the rest 50 rows into the test set x test. Okay, similarly we'll do for the target values also, the y values also. Then as they are asking the SVM with some particular setup, C values they are asking to take 0 0.01, 1 and 100. So we have taken it in an array so that all the three accuracies in a loop we are going to get. Okay. Then for each C value, for the first C value, suppose for 0.01 first time, we need to use this SVC. Where we got this SVC? We got it from the SVM module of the sklearn library, which is our SVM classifier. And the kernel we need to use RBF. Gamma value they are asking to use 0.5, and C value, whatever the C value will, it will keep on looping. And we need to use what? One versus rest. Okay, that is this my over here. This is a variable called decision function shape. Okay, so under this setup we have created this SVM, and then now I'll feed my X train and Y train, my training data, on this SVM. So using this feed function I am training my data, training my model. Okay, then after training the model, this SVM model, we will predict using that model on the X test, on the test data set. Okay, and we have saved the prediction values, prediction class levels, and finally we will compare this Y prediction from the model and the original Y test values. Okay, and finally we'll get the accuracy. So all the accuracies will print here, and the best one will print here at last. So let me run this program. So after running this program, you can see that for the first C value 0.01, the accuracy value is 0.32. For the value C1, accuracy is 0.98, and for the last 10, C equal to 10, the accuracy is 0.98. Okay, again the accuracy is same with the C equal to 1. So the best accuracy out of all these three is 0.98. Okay, which is we got from C1 as well as from C10. Now if we go back to the question here, what are the available options? For the above set of hyperparameters, report the best classification accuracy. So it has the option 0.98, 0.88, 0.99 and 0.92. So here the first option 0.98, this is the correct option. Okay, thank you.